video, I'll discuss about multivariable function. Well, you guys are quite familiar with the word function and you have learned about it in calculus. So before going into complexities, first I would like to give you very simple examples so you can easily learn the concept of multivariable function. Here we have three examples of single valued functions which you have studied in calculus. So in the first example, we have the formula for area of a square, which is x square, and x is the length of each side of the square, and you all already know that the length of each side of the square is same. So here we need only one value to get the area of a square, and this one value is the length of the each side of the square. So in the next example, we have area of the circle, which is pi r square, and r is the radius of the circle. So just like previous example, here we need only one value to get the area of the circle. In volume of the cube, we have its formula a cube, where a is the length of each edge of the cube. In cube, the length of edges is same, so here we need only one value to get the volume of the cube, and that one value is the length of edge of the cube. So these three are very simple examples of single valued functions. Well, here we have some examples in which we need more than one inputs to get the required output. So such type of functions are called multivariable functions. So here you can see area of a rectangle is x plus y, where x is the length of the rectangle and y is the width of the rectangle. So here we need two values to get the area of rectangle. One is width and one is length of the rectangle. In the area of a triangle, here we need length of the base b and height of the triangle. So in this example, we need two inputs to get the area of a triangle. Well, here we have volume of a cylinder and it requires two inputs, that is radius of the circle and height of the cylinder. So to get the volume of the cylinder, we require two inputs to get the volume. So in these three examples, you can see we have to input two values to get the required output. So such type of functions are also known as bivariate functions. In the volume of the box, here we need three inputs, that is length, width and height of the box. So this is also an example for multivariable function. So if we need more than one input to get the required output, so these types of functions are known as multivariable functions. Well, before going to the multivariable functions, let's first take a review of single variable function. You guys are quite familiar with this expression y is equal to f of x, where x is input value and y is output value, and f is the rule which basically leads us to output. Now here formally x is independent variable and y is dependent variable, because y depends on the value of x. So here you can see we have single independent variable and single dependent variable. The function with single independent variable is known as single variable function. Now let's move to the multivariable function. Now here you can see the independent variables are x and y, and dependent variable is z. So here you can see we have more than one independent variable, and we can write it as z is equal to f of x, y. Here inputs are x and y, which are more than one. Here we have two inputs and one output z. So this is multivariable function, and we can also call it bivariate function. So in this expression you can see here we have three independent variables and one dependent variable. So if we have more than one independent variable, these type of functions are known as multivariable function, and here we can write it as w is equal to f of x, y, and z. Here x, y, and z are input values and w is output value. Now let's go through the formal definition of function of two and three independent variables. A function of two variable x and y is a rule that assigns a unique real number z to each point xy in some set D in the xy plane. So here the important thing is xy plane. So here the input is not a single real number. Here we have the input in the form of ordered pair, which is the point on the xy plane, and output is the single value z. Function of three independent variable. A function f of three variables x, y, and z is a rule that assigns a unique real number w to each point x, y, z in some set D in three-dimensional space. Now here the input is the point on the space. Now if I talk about difference between function of two independent variable and three dependent variable, if I talk about the graphs of these functions or the difference between these two functions, we can say the function with two independent variables are the hollow surfaces, and the function with three independent variables are solid surfaces. So the function with two independent variables are 3D surfaces, and functions with three independent variables are 4D surfaces. So basically 4D surfaces are solid surfaces and 3D surfaces are hollow surfaces. Now let's take a look at some 3D and 4D surfaces. In this example, we have function f of xy is equal to x square y plus 1, and we have to find its value at 2, 1. Now here x is equal to 2 and y is 1, and we have to find the value of this function at 2, 1. So let's find it. Here we have to put 2 in place of x. So here is the square of x, and y is 1. We will put 1 in place of y plus 1. So here square of 2 is 4 into 1. plus 1, which is equal to 5. So the output is 5 for the input to 1. So just like we have done in calculus, the difference is in calculus we have to put single value in the function, and in multivariable functions we have input in the form of ordered pair or triplet and so on. Example 2, we have function with three independent variables x, y, and z, and it is defined as zxy plus x, and we have to find its value at point 212. Now here we have x is equal to 2, y is 1, and z is 2. Let's now put these values in the given function. We have to find value of f at 212. So z is 2, x is 2, and y is 1 plus x is 2. So it is 4 plus 2, 6. So the value of f at 212 is 6. So we can easily find the output at any point. We can easily find the output at any point, whether it is single valued function, bivariate function, or multivariable function.